Now let's just move on to the question number 2, which says that find a quadratic polynomial each with a given number as the sum and the product of its zero. It means the sum of the zeros and the product of its zeros is already given to us and we have to find out the quadratic polynomial. So let's just find out the quadratic polynomial with another method, not by comparison, by another method. So let us suppose we are starting with the solution set of the very first part. So for the very first part, what we can say, we have the sum of the root. So let's just write it. We have sum of the roots is equal to root 2. The very first value is the sum of the roots, and product of the roots is nothing but given to us as 1/3. So let alpha and beta be the two roots of the quadratic polynomial, hence the required polynomial can be expressed as x square minus sum of roots into x plus product of the roots. This is nothing but the required quadratic polynomial, which can be expressed as x square minus sum of the roots into x plus product of the roots. We can also find it with the help of the comparison method like we did before, but using this particular equation or the required polynomial, we can find out the answer in a very easy manner. So hence the required polynomial can always be expressed into the formation of x square minus sum of the roots into x plus product of the roots. So using this particular concept, what we can say the quadratic polynomial can be expressed as x square minus alpha plus beta into x plus alpha into beta, sum of its roots and the product of its roots. So if alpha and beta are the two roots, then we can express it as x square minus alpha plus beta into x plus alpha beta. Now let's just substitute the values over here. As we know, the sum of the roots is alpha plus beta, which is root 2. The product of the roots is alpha into beta, which is 1/3. So using these two equations, what we can say that x square minus alpha plus beta is nothing but root 2 of x plus alpha into beta is nothing but 1/3, is nothing but the required quadratic polynomial. And further, let us suppose we will take the LCM as 3x square minus 3 root 2x plus 1 divided by 3. We can take divided by 3 as well, and this is the required, or we can say this is one of the quadratic polynomial, but we are neglecting the denominator over here. Because like we did before that in the previous question, we do know that we have found out the answer with the help of the comparison method, and at the end we have concluded that the given quadratic polynomial was one of the quadratic polynomial, and there are many other quadratic polynomial which can be expressed into the formation of k into ax square plus bx plus c formation, where k is any kind of the constant. So using that particular concept, we can neglect the denominator of this particular quadratic polynomial, and we can say that 3x square minus 3 root 2x plus 1 is one of the quadratic polynomial which can be expressed in a way that the sum and the product of its zeros are root 2 and 1/3. So this is nothing but our answer. Here we have neglected 1/3 or the denominator 3. Now let's just talk about the second part. In the second part, again, what we can say the sum of the roots. Is given to us, which is nothing but is equal to 0. We can express it into the formation of alpha plus beta. Again, we can express it as alpha plus beta. Further, the product of the roots is nothing but mentioned to us, which is root 5. We can express it as alpha into beta. Again, let alpha and beta be the two roots, let alpha and beta be the two zeros of the quadratic polynomial, hence the polynomial can be expressed as, hence the polynomial can be expressed as x square minus alpha plus beta into x plus of alpha beta. Let's just substitute all the values in here. We will get the answer as x square minus alpha plus beta is 0, x plus alpha beta is nothing but root 5. So at the end, x square minus 0, x plus root 5 is our answer, or we can write it as x square plus of root 5 is nothing but the given quadratic polynomial in which the sum of the roots is 0 and the product of the roots is root 5. So always remember this concept that whenever we have any two zeros given of any quadratic polynomial, then the quadratic polynomial can always be expressed into the formation of x square minus sum of roots into x plus product of its roots, or in the form of x square minus alpha plus beta into of x plus alpha beta. So using this concept, we can able to find out the quadratic polynomials.